Hi, 7th grade. Okay, today we are working on page 23. The kids in class got probably like a 30-page packet and they put it in their binder. You at home, you have not received this packet yet, so what your job is to write down everything I'm doing in your notes. And then when you guys come back, I will check all of those notes at once. So don't worry about taking a picture of them or sending them to me via email. Just hold on to them, and then I'll check them when you guys get back. So the kids in class, you guys have this in your binder. Kids at home, you guys do not. You will have to take notes on these. All right, so kids at home with notes, you're going to write Chapter 2, Fair Game Review at the top of your paper. Now, kids here, we talked really quickly about how to write decimals as fractions. Does anybody remember? How do you write a decimal as a fraction? Christine?
You count how many places went over.
Uh-huh.
You count, and then so for number 1 it'd be 26 over 100 because it goes
Good.
over 200.
Good. So I always ask kids, what number do you see? 26. So you write 26. And then how many spaces does that 26 take up behind the decimal? 2, which means you'll have 2 zeros in the bottom. It's always a value of 10 somehow, right? So your answer is 26 100ths. Now you always need to reduce when you can. How could I reduce this one? Flora?
You can divide it by 2.
Good. Take out a 2 in each of these with division. What's 26 divided by 2? 13. What's 100 divided by 2?
50.
And are we done? Do we have to reduce again?
No.
We're done because I know nothing times anything is 13, right? All right, so that's my final answer. Always circle your final answer, okay? All right, number 2. What would this one be as a fraction, everybody?
79 over 100.
Okay. Can that one reduce?
No.
Nothing times anything is 79, right?
Because it's odd.
Very good. How about this guy? What would this be as a fraction?
471 over 1000.
Good. Yuma says there's 1, 2, 3 digits back there, which means there'll be 1, 2, 3 zeros. Now, can this one reduce?
No.
571. There are things that equal 571. Like if I take my calculator and I say 571 divided by 3. Oh, no, that didn't work. 571 divided by 9. No, that didn't work. Divided by 4? Ooh, we're getting kind of close. Would 571 divide by 5 nicely?
No.
How do you know that for sure? Christine?
Well, because if the numerator ends with a 0 or a 5, then you can divide it by 5. But
Good.
it doesn't, so it won't show anything.
Yeah. Guys, this one does not reduce nicely. We're just going to go ahead and circle it. That's our final answer, okay? Taryn, do you have a problem? Okay. Did you need a pencil, Taryn? Okay. Did we do number 4 together yesterday, guys?
Yeah.
Okay, what was the answer to this one?
423 over 500.
Good. You guys are saying this one reduced, didn't it?
Yeah.
It reduced by 2, 2.
Please excuse the interruption. Teachers, could you release all the middle school tennis players to go get on the bus? Thank you.
All right. Hey, middle school tennis players, you guys can watch this video. It's in the Google Classroom. Are you guys in the Google Classroom?
Yes.
Okay. I will post this video to the Google Classroom tonight. Watch it. At the end of the video, it'll tell you what your homework is. Okay? So in your planner, write down, watch video.
I hate going on buses and it's cold in the bus. So it smells like a seat that is cold.
Okay, we're doing number 5 now. Zip it. Boop, boop. Number 5 says, do you want one? Okay.
So when you sit on the seat, it just feels like a
Here you go,
really
Taryn.
cold seat, and I just hate it.
All right, guys, 5 through 8. Did we do those yesterday?
No.
No. Okay, so here's what I want you to do. Over here in that kind of like empty section, we're going to take a note, okay? You might use your highlighter to highlight it. To turn fractions into decimals.
Just divide.
Yep, just divide.
We did a little bit yesterday.
Okay, good. You guys wrote that down?
We did number 5 yesterday.
Okay, and then what does that fraction bar actually mean?
Divide.
Yes, the fraction bar actually means divide. So let's also take a note on that and say fraction bar means divide. Okay? Go and take that note, people at home too. Just divide. Fraction bar means divide. So over here, 3/8. You guys said we did this one together in class, right? Just divide 3 divided by 8. We learned that 8 goes on the outside, 3 goes on the inside. How many 8s can go into 3? None, because 8's too big, right? Can't go over. So we put a 0. Now we put decimals and line them up. Give another 0 to the 3. And now don't read it as 3.0, read it as 30. How many 8s can go into 30 without going over? 8 times 3 is?
24.
Okay, so subtract that out. You get 6.
16.
Bring down another, oh yeah, you're right, 16, right?
Yeah.
Oh gosh, I don't need another 0, do I?
No.
Oh no, it's not 16. Minus 2, this should be 6.
Yeah. It would be just.
Bring down another 0.
Uh.
How many times can 8 go into 60 without going over?
8.
7.
7.
7 times 8 is 56. Subtract that out, you get a 4. Bring down another 0. How many 8s can go into 40? And that worked out perfect, didn't it? Because when you subtract those, it's 0. You're done. Now, your final answer is, and I always want you guys to circle your final answers, it's 0.375, circled. Okay? Try to get in the habit of rewriting your answer elsewhere. Don't circle this on top of the long division problem. Okay?
We also need your Google Classroom thing.
Your Google Classroom code? Okay, I'll make sure you guys get that before the bell rings today, okay? Okay. 4/10. Hey guys, how do you say this fraction?
4 divided by 10. I mean.
4/10?
Yeah. 4 times.
Didn't I just say out loud what the decimal would be? The decimal? What's the decimal? 4/10?
Yeah.
How do you write 4/10 as a decimal?
0.4.
It's just 0.4? You don't have to put the 0, just put 0.4. 4/10 is 0.4. That's it, right? Now, if you didn't remember that, remember, tens are super easy. All you do is you say the fraction how you would say it, and that's how you would also write it. Remember the place values? We got tenths, hundredths, thousandths, 10,000ths, right? So whenever you see a form of 10 in the bottom, even if it's 100 or 1,000, those ones are super easy. You just write it as you say it, okay? Okay, so that's the answer. Let's do number 7. 11/16. Now, we didn't do this one in class together, right? Brand new. How do you write a fraction as a decimal? You just divide. Who goes inside?
11.
Good. How many 16s can go into 11?
9.
None. Put the 0 above the ones place of the 11. Then put a decimal and add a 0. Taryn? Gotta have it over your, off your eyes, okay? Okay. How many 16s can go in 110? Well, gosh, if I multiplied 16 times 10,
160.
I'd get 160, so I know it's gonna be lower than 10. What's 16 times? Yeah, I know, I can hear it. Let's go out there and clap. I'll go ahead and pause this.
A few moments later.
All right, sorry guys, we had to go outside and do the clappity thing for homecoming. Anyway, here, this is where we were, correct?
Yes.
How many 16s go in 110?
6.
6.
7.
7.
Here, want to know a hint? I'm thinking it ends in a 0, right?
Yeah.
Yeah.
What multiples of what ends in 5s and 0s?
Oh, 5 or
5s?
5
What's 16 times 5?
30. I mean,
82. 80.
5, 6, 7, 8. That's 80. Oh gosh, I thought I was on the right track here. Maybe we got to keep going up, right? 16 times 6. 6 times 6 is 36. 6, 7, 8, 9. 96. That's probably as close as we're gonna get. Do you guys agree?
Yeah.
I think so too. So put a 6. We got 96. Subtract that. 14. Bring down a new 0. Ooh, 140. Now we know we can go higher. So what's 16 times? I know 16 times 10 is 160. How about 16 times? How about 8? 6 times 8 went on a date. Then they came back with?
48.
8 times 1 is 8. 9, 10, 11, 12. 128. Oh my goodness.
9.
6 times 9 is 54.
That's the closest we can get.
9, 10, 11, 12, 13, 14. Uh-oh.
Yeah, that's the closest we can get to.
So 16 times 8.
Yeah, we have to go with 8. We can't go over, right? So it's 128. Subtract that out. Oh my goodness gracious. Bring down a 0. 120
16 times 7.
times 7. What was 16 times 7?
16
It would
times
be
8.
12.
What? 16 times 7? 7 times 6 is gum on your shoe. 42. 7. 8, 9, 10, 11. 112. You think that's as close as we can get?
Yeah.
Yeah. Darn. We're just like so close each time, aren't we? Okay, so now that's 112. Subtract that. What do we get?
8.
Bring down a 0.
5.
Oh, 5. 5 was perfect, wasn't it? 5 times 16 when we did it was 80, wasn't it?
Yeah.
Hooray! Now I know that seemed really long, and a lot of kids, after they get to like this point, they'd be like, maybe it's just gonna go on forever. Let's just be done. Don't do that, okay? Keep doing it. Keep doing it. Chances are it's gonna finish, right? Now, here's my guideline for you guys while long dividing on your own. If you do it 5 places, so we would have done it one more time, right? If you've done it 5 places, then I would say just stop and we'll just consider whatever you got right here is the answer. Okay? No remainders. We don't do remainders anymore. Okay? I think just to teach you that things can go on forever and you can just stop when it's time. But what I want you guys to do is just go to 5 places, and if it's still going, just stop. And then that would be your answer. Okay? Did you know fractions and some decimals can go on forever and ever and ever? Yeah, some repeat forever, some don't repeat, but they just have numbers forever, right? Okay, let's go ahead and do 8 together. 17 divided by 20. That's how you turn it into a decimal, right? Who goes inside?
17.
Who goes inside?
17.
Or sorry, outside is 20. How many 20s can go into 17? 1. Wait, what?
0.
Silly gooses.
Oh, yeah, no, that's 17.
How many 20s can go in 170?
20, 40, 60, 80, 100,
Ooh, Christine's counting by 20s. That's smart.
160. 8 times 8 would equal 160.
Perfect. Good thinking, Christine. To count by 20s.
It'd be 100.
10, you mean?
No, and it'd be 5.
So you're saying it equals 10, bring down another 0.
Yeah.
Now it's 100. Oh, this will be nice.
4.
50.
No,
Oh, no.
5, not 50.
5? 5 times 20 is 100?
Yeah.
Oh my goodness, I'm so glad they gave us a nice one because that last one was kind of long. What's my final answer?
Bless you.
Oh my god.
Arrow, are those for real?
Best.
Oh my goodness, Arrow. Those are the most fascinating sneezes I've ever heard in my life. Holy smokes, dude. Hey, you know what I realized?
My whole entire life was that.
You know what I noticed about my page? I forgot to circle the final answer here. And I never circled the final answer over here. Make sure you guys get in that habit, okay?
Your sneezes are gonna be.
Yeah, your sneezes are forever ever on history in this video. That's awesome. Number 9. A quarterback completes 6/10 of his passes during a game. Can you guys write that as a fraction?
Yeah.
How did I say it?
It's harder to see.
6/10?
Yeah.
Isn't that just 6?
And then
Tenths?
6 over 10.
Oh, good job. You guys are saying we can reduce.
Yeah. And
What do I take out for each of these?
2
A 2?
would equal 3 over 3, 5. 5. Yeah.
3/5, and
Yeah.
that cannot reduce any further, correct? Okay, that means 3 out of the 5 times he completes his passes. Interesting. All right, guys, go and turn to the next page. Page 24. This will be your homework, but we're going to do half of it together, okay?
Are you
Also, do you see this blank space right here? we're going to take some notes right there. Okay? Here's the first note I want you to do. As you can see, 10 and 11, what are we doing to those fractions?
Adding.
Do you guys remember a special rule about when you add and subtract fractions? Do you guys remember a special rule about when you add and subtract fractions? What do you have to be able to add and subtract a fraction?
Denominators.
Wonderful. Adding and subtract fractions, you need common denominators. The denominator is the bottom number. You have to multiply things around to make them the same number. How many of you guys are now remembering what a common denominator is and how to do it? You remembering this? Okay, we're going to do 10 together, but not 11. 11 is for you. You're not going to do it now, though. We're going to skip it. We're going to do this whole column right here is what we're going to do together. This whole column will be your homework, okay? Okay, number 10. I need common.
Denominators.
Now, here's a trick. If you've got two small numbers that don't really have anything like really in common early on, I would say just multiply them together. What's 9 times 8?
72.
So your common denominator would be? Okay, so here's how I write it. I rewrite it below. Do the denominators first, okay? I want you guys to get in the habit of writing it like this. This is a good way to keep it organized, okay? Now, 8 times what got you 72? Do it to the bottom. You got to do it to the top. What's 9 times 1?
9.
Okay. How did 9 turn into 72?
8 times 8.
Okay, so if you do it to the bottom, you got to do it to the... There we go. Now, when adding fractions, you just add the numerators. You leave the denominator alone. So it's going to be something over 72. What's 8 plus 9?
17.
17? Is there anything times anything that gets you 17?
No.
No. So when I ask that, I'm wondering, can I reduce this?
No.
No, that's my final answer. Go and circle it. Okay, let's do 12. 12 is just like 10, where you have to have that rule of you need common.
Denominators.
Okay, what would be a good common denominator for these fractions?
48.
Well, you could multiply them, but then that means you'd have to reduce in the end. But I see a least common denominator.
Which is 4.
I can't turn a 12 into 4 with multiplication.
So turn a 4 to 12 by
Good.
3.
So what would be a good common denominator with these two? 12. Excuse me. Are you listening? You should be talking. You should be looking at the board and writing these things down. Isaac, what's a good common denominator for this?
48.
Nope, we just said out loud that we're not going to do 48 because then you'd have to reduce. 12. Good. Can I leave 7 12s as it is? Yeah, let's just rewrite it. 7 12s. Now, how did I make that 4 into a 12?
You times it by the 1 by 3. Yeah.
We times it by 3 to get 12, right? So then do the top by 3.
Which you,
Now, just like addition, you keep the denominator the same and just subtract the numerators. 7 minus 3 is? 4. Now, 4 12ths, can I reduce that?
Yes.
By- Okay, so I'm taking out a 4 on each of these,
yeah.
and that would equal 1 third. There you go. Any questions on 10 and 12? How do you add? How do you subtract? Do you need a common? Okay, now come on over here back to the blank area. We're going to take another note. Ready? When multiplying, oops, that's a G. When multiplying fractions, do you remember how to multiply fractions? No?
Yeah.
This one's super easy. I think my favorite thing to do with fractions is multiply them. Perfect. Yeah, Yuma, you got it. Yep, did you guys hear what Yuma said? Here's how you do it. You do numerator times numerator over denominator times denominator. You just multiply straight across. Okay, so for example, look at number 14. Take your numerators and times them, and take your denominators and times them. What's 5 times 1?
5.
What's 9 times 3?
27.
That's it. That's your answer.
I know.
Love multiplying fractions. So easy, right? Just tops times tops, bottoms times bottoms. Okay? Is that the same rule for division?
No.
You guys learned a cute little thing when you were in school for division. When dividing fractions. What was your cute little thing you remember in school?
How to like turn it around
Yes!
on the second fraction.
Good! Do you guys remember learning skip,
Skip, flip, multiply.
flip, and multiply?
Oh yeah, we learned that last year.
Do you want to know what the real word of that is? I think you know it. The multiplicative.
The multiplicative inverse.
Good. Skip, flip, and multiply is baby talk for the
Multiplicative inverse.
the multiplicative inverse. The multiplicative inverse just says multiply the first fraction by the reciprocal. That's a new word, right? Reciprocal means you flipped your fraction. Okay? You just multiply by the reciprocal. So skip it, 7/8. Flip it, 16/11, and you
Multiply!
yeah. Okay, now guys, when you multiply fractions, you just do tops with tops, bottoms with bottoms, numerators with numerators, denominators with denominators. What's 16 times 7?
It'd be
We did!
12.
112, good. That's funny that you remember, we just did this. And 8 times 11, that's easy, that's 88. Now, oh my gosh, what do we call fractions when the big number's on top?
Ooh,
You just add a 1.
isn't it like
What do we call those? They're called something. I hate them. They're called
Whole number.
improper.
yeah?
Guys, do you see this little fraction that you just wrote? Go ahead and put an arrow right there and say improper.
Yeah.
And take a highlighter and highlight that. I want your eyeballs to go right to it when you see it. Improper. Ugh. We don't like those. They're nasty. I've got a bucket of highlighters right there, buddy boy. Do you guys remember there's highlighters in the buckets?
Hi!
A ton of them.
Lock it.
Mr. Thompson's going to learn how we turn improper into something else. They're ugly. They're the worst. They're like gremlins.
Well, that's just rude.
No, it's not rude.
Insulted my brother.
They're the worst.
That's insulting me.
Now listen. I can turn improper into something else. Psst, Christine, what do I turn improper into? It has a word. It's a fraction with like a whole number to it, right? But what are those called?
Mixed fractions.
Woohoo! Got an arrow. We're turning improper into. You can catch it? Yuma needs a quarter for why?
Because he's gonna answer.
What did he remember?
And we did it
The
a couple-
skip, flip,
Okay. Ready, Freddy's? Ready?
Quarter.
Zip it. Let's do this. Arrow just said to turn an improper fraction into a whole number and a fraction. Those are called nope. Mixed mixed numbers. Mixed numbers. Highlight that too. Mixed number. A mixed number has a whole number and a fraction. Do you remember how to get there? I hated these as kids. This was my least favorite thing. Yeah, kind of. Yeah.
You just put, you multiply.
Kind of, yeah.
Like you put.
Yeah, you use multiplication to figure this out, right?
But then you also add.
Good. Okay, look right here. You ready? Here's my trick. Ask yourself, how many 8s can I take out of 112 without going over? How many 88s can I take out of 112 without going over?
1.
1. Now, see that 1? Make it a big 1. That's one thing you could take out, right? Okay, now watch this. Take the big number you just made. Sometimes it's a 2, sometimes it's a 3, sometimes it's 184. I don't know. Take the big number, multiply by an 88. What is 1 times 88?
88.
And subtract that from up here. Okay, minus 88. What's 112 minus 88?
24.
you guys right about that? Should I listen to you?
Yeah.
Oh, yeah, you should always listen.
I should always listen to you. I should always. Okay. Now you keep the denominator the same. So that's my trick for turning improper into mixed. You see how many of these can come out of here? You write that as a big number, multiply the big number to the denominator, and take it out of here. Okay? Okay? Now what do you guys notice about this?
You can reduce it
How did you know? How did you know just by looking at it right away?
because they're both even.
Yes, they end in even numbers, which means I can take out a...
2,
Yeah, is there anything bigger I could take out though?
4,
8, 3,
4,
Whoa, I hear a lot of things. 8?
8,
8 times what is 24?
3,
3,
8 times what is 88?
11.
Let's take out an 8 and an 8. What times 8 is 24, you just told me?
3,
What times 8 is 88?
11.
11.
Can I reduce 3 11s?
No.
No. Can I show you what a lot of kids do on accident? They do that correctly and then they go, here's my answer.
No, you forgot the 1.
Oh, I forgot that big whole number. I did all this math in between and I forgot that this guy existed, right? Please, please, please try to remember that you had a whole number there and then write your new fraction and circle it, okay? There's your answer. Bada bing, bada boom. Okay, so your guys' assignment, we're going to do 18 together, but your assignment tonight will be to do 11, 13, 15, 17, okay? Yep, all those odd numbers. And in your planner, I would like you to write, it's page 24, but don't just write page 24 because what are you going to do? You're going to go to your book and go to page 24. And is this in your book? No. I want you to write page 24 binder work because it's in your binder, right? And then just say do the odds. Deal?
That's
Sweet.
cool, thank you.
Yeah, you learned about improper.
I did.
Ugh. We hate improper.
You're
Ugh.
scaring Mr. Thompson away.
You're scaring me away. You're scaring me.
18. Ready, chickens? You have 8 cups of flour. The recipe calls for 2/3 cups of flour. Another recipe calls for a 4th cup of flour. How much flour do you have left after making the recipes? So I guess what you did is you made this recipe and you made this recipe, but now how much do you have left? So hold up. Who remembers how to turn whole numbers into fractions? Here, this will be another little note we'll take. How do you turn whole numbers? Whole number is just like the number 8, right? How do you turn whole numbers into fractions?
Well, you just do 8 over 1.
Perfect! You just take that whole number and put it over 1. And is it a fraction now?
Yeah.
It sure is. So please, over here, turn 8 into a fraction for me. Now, this just turns into a simple subtraction problem, right? I have 8 over 1, take away 2/3, take away 1/4, right? What do I need when adding or subtracting a fraction?
Common denominator.
You need common denominators. Here's a quarter. Catch it. Good catch. What is a good common denominator between 1, 3, and 4?
4.
12.
Okay, hold on. You said 4. Could I turn a 3 into a 4?
No.
No.
I said no.
What did you guys say?
12.
12. Now, please get in the habit of rewriting it down below. I'm going to take a little piece of scratch paper and hide my extra junk down there so we don't get confused. Get in the habit of rewriting it down below. So we're turning everything into 12, right? 12, 12, 12. We're still subtracting, still subtracting. 1 times what got you 12?
12.
So if I do it to the bottom, I got to do it to the...
12.
What's 8 times 12?
84.
Close. 96. Good. Now, how did I go from 3 to a 12? So do it to the top.
8.
Okay. How did I get 4 to turn into a 12?
3.
Okay, so if I do it to the bottom, I got to do it to the... Okay, now this is just a simple subtraction problem, except for I'm going to keep the denominator of 12. Okay. What's 96? Take away 8,
88.
and then take away 3.
85.
85.
Oh my gosh, what is this?
Improper.
It's improper. Ugh. We don't like improper, do we? Nasty. Remember my trick? Ask yourself, how many 12s can I take out of 85 without going over? Well, let's see. 12 times 5 is 60, right? On a clock.
So
Seven.
7.
7? What's 12 times 7?
72.
84?
84.
Ooh, that's real nice. That's real close, isn't it?
Yeah.
Okay, so how many 12s could I take out of 85? 7. That's your big whole number. 7.
7, 1, 12.
Now remember, take the big number times the denominator that you guys told me that was 80
4.
and subtract it from the top. What's 85 take away 84?
1.
1 and keep your denominator. There's your final answer. So how many cups of flour do you have left?
7 and 1, 12.
Yep, 7 and 1/12. Let's label it. 7 1/12 cups of flour. Yes, you may.
Can I use this?
Yes, you may. All right, guys. So that is it for your lesson today. Your homework is 11, 13, 15, and 17. Those of you at home, remember you should have all of this written just in your notes on paper, okay? All right.